Okay, now we're going to talk about different types of drilling fluids. Drilling fluids can include water or water mixed with minerals. This is typically a bentonite clay or synthetic polymers. When the drilling fluid includes mineral or synthetic additives, it's commonly referred to as a slurry. The addition of minerals or polymers is used to help contain the fluids within the hole, and that minimizes fluid loss through seepage out through the borehole wall and thereby maintains a positive head pressure. So we'll talk about how each of these can be used to maintain stability during construction of drilled shafts. Water alone can function as a drilling fluid in situations where the formation is inherently stable but permeable, such as some rock formations as noted earlier. Casing may be employed through unstable overburden to provide a stable environment to excavate the rock using only water. If the soils are cohesive or cemented, it may be that water can simply be used to maintain the inherent stability by mitigating any flow of water into the hole from the surrounding ground. Without adding water, flow going into the excavation can destabilize soils or rocks that might otherwise stand. So this situation is to be avoided. If we see significant amounts of water flowing into the hole, the right thing to do is to flood the hole by adding water so that the inflow is reversed. If we just wait until the hole fills up, that's not going to work, because every time we remove some material, there will again be a situation of inflow that can destabilize or bring in materials from the surrounding soils. With casing down to rock, it may be possible to seat the casing into the rock and seal it sufficiently that no inflow will occur, and then we have a dry excavation into the rock. However, the top of rock is often irregular and the uppermost layers may be weathered or broken or contain soil seams, which can result in flow into the socket. And it can be difficult to get the casing sealed in circumstances like that. So in these conditions, it's desirable to maintain a fluid head of water sufficient to avoid infiltration in the rock socket, and particularly around the bottom of the casing if a complete seal cannot be achieved into impermeable rock. If we don't add water and keep a positive head, an inflow of water occurs around the bottom of the casing, then this inflow can create a void on the outside of the casing above the rock surface if fines are washed into the rock socket. A noticeable quantity of overburdened soils coming out of the rock socket excavation could be a telltale sign that inflow may be occurring. So we don't want this condition. The voids could lead to subsurface subsidence around the casing, even extending all the way to the surface in the form of sinkholes. If the casing is temporary casing, we could lose so much concrete flowing out into the void when the casing is extracted that there could be a breach and mixing of concrete with the water that's in this void. Positive water head may be needed where full-length casing is employed to provide sidewall stability in permeable or unstable soils. In this situation, a positive water head is needed to avoid upward directed flow into the base of the excavation. This upward flow could produce softening of the material at the base, even liquefaction of cohesiveness soils. In some cases, instability at the base could lead to a flow of soil up and into the casing, with the attendant loosening of the soil around the excavation and possible subsidence at the ground surface. So don't do this. A positive water head within the casing, often with a plug of soil at the bottom of the casing, is used to mitigate the risk of instability at the base. That plug of soil, besides providing some confining pressure at the base, also helps to contain the water within the casing, because now it has to flow through several feet thick plug. So more details on construction with the fully cased method is provided in the lesson on casing, and some discussion is in the lesson on techniques for excavating. Water may also be used as a drilling fluid for rock excavation with tools and equipment that utilize fluids to flush cuttings from the excavation face. Examples include percussion tools, double-walled core barrels, or full-face rotary tools like the reverse circulation drill that you see in this photo. There's more explanation of how these tools work in the lessons on equipment, but the characteristic we're talking about here is the use of water as a drilling fluid to circulate and flush the cuttings from the cutting face that you see here on the right up through the airlift pipe to convey the excavated materials to the surface. Air may be used as a flushing mechanism in some tools, with the hole filled with water to maintain a positive head in the excavation. This tool is a percussion drill, and the fluids are lifting the cuttings from the bottom of the hole to a catch basket that's located on the top of the tool. So more details on the construction of these types of tools and photos of the catch basket and how this all works is available in the lessons on techniques for excavating. So when we talk in general about drilling fluids, we're not just discussing slurry. The use of water in the excavation certainly represents a significant aspect of advancing construction and maintaining stability. So next we'll talk about slurry drilling with mineral and synthetic admixtures added to the water.